Hello students, welcome to Shorop sir classes. So in this particular video we'll be solving the question from the ISI admission test of MTech program for the MTech program. So this is question number 4. Let X be a non-empty set and that P of X be this power set. So we have to define the two operation plus this addition and the multiplication on this particular the power set we have follows. So for A and B is an element of this power set. So we have defined that A plus B is nothing but A union B and A star B is A intersection B. So now we have been given these two groups, this G1 and G2 with this power set and the operator. So we have to find which one of this is a group or is either this G1 is G2 is a group or not. Okay. So this is the question. So first we have to go through this check the group by group. So first one we will take this group 1. So G1 is given as the power set of X and plus this addition operation. So we will check the properties of the group with this G1. So if it satisfies, then you can only say that it is a, so G1 is a group. So first the first point, this point 1. So let we have been given this AB is an element in the power set. So we can write that A union B will also belong to this particular power set Px. So from here you can say that Px is closed under the addition operation. Now point 2. So if this A union B is union of C, so we can write it at A union B union C. So this from here we can infer that associative it also follows, right? So number 3 we will check with this group that phi is belongs to this power set. Okay, so if we do this, write A union of phi, which is simply A, we can also write that phi union of A. So from here we can also infer that the null set, that is phi, it is an identity. And the last one for this property, that if we take that if A is a non-empty set, if A is a non-empty set, then this A union B will be a superset of A, right, which is not equal to the null set. So from here we can infer that A has no inverse. So we know that when A is no inverse, then we cannot say that G1 is a group, so it is not a group. Now let's go with this G2. Okay, in this case we will see, so it is G2 is equal to this power set of X and the star operator. Similarly we can write this, that let this AB, since this AB is an element in the power set X, so simply we can write this A intersection B is also an element in the power set X Px. So from here we can infer that Px is closed. So this is first of the inference we can get. Now if we write this, that A intersection B intersection C, so it can be written as A intersection B intersection C. So from here we can say the associative law also follows. Okay, so the point number 3, suppose X is an element of this Px, the power set X, then A in this A intersection, so A intersection X, it will be simply A. Okay, for all A in the belong to this Px, right? So here X is the identity. right? Now if we see the last option, whether this group has an inverse, so this option 4. So here we can see that suppose this phi is an element of this power set Px, right? If we do this phi intersection A, it will give us this null set phi. So which means that for all A in this belongs to this element of Px, right? So from here you can see that phi doesn't have any inverse. This phi does not have any inverse. So we can say that this particular Px star, that is G2, is not a group. So we have checked with the properties of the group, and we have find that G1 is also not a group, and G2 is also not a group. Okay. So if we check with the options, then the correct option for question number 4, it will be option D. Neither G1 nor G2 is a group.